Hi everybody, we're back. We're starting a new chapter today, so we're getting into matrices. This is going to be the last chapter of the whole year, so we are almost done. There are like 5 more video lectures or something, and then the year is up. So matrices is where we're at. I posted on the Google Doc that if you're taking calculus next year and you're interested, there were 2 things that we didn't cover this year due to shelter in place. That was parametrics and also polar. And if you're interested, I've linked websites that get you guys to curriculum that you guys can look over this summer or whenever you guys have a minute. That's if you're taking calculus or future math classes, it might be useful. Okay, this video is a review of Algebra 2 concepts, all about solving systems of equations the way that we did in Algebra 2. So if that was something that was really solid for you last year, then I don't think you're going to need to watch this video. The notes handout answers are posted on the class website, and all you guys are asked to do for this homework assignment is just either follow along with the lecture and fill out the lecture notes or do them on your own, making sure you show all of the work. So up to you guys what you choose. But again, you might not need to watch this video if you guys were good last year at solving systems of equations. Okay, let's get into it. Notes 11.1. We want to verify first that the values of the variables are solutions to this system of equations. So knowing what we know about variables and such, if we plug in 2 everywhere we see x, 1/2 everywhere we see y, we want these 2 equations to be true. If they are both true, that means that we've got a solution to our system. So I'm going to label these A and B, and I'll do that as we go through this set of examples. But if I replace x with 2, and y with 1/2, do we get something that is true for equation A? We get 6 minus 2 is equal to 4. 4 is indeed equal to 4, so that works for equation A. We have to check both equations though if we want to say that it is a solution. So I am also going to replace 2 for x in the second equation and 1/2 for y and see what happens. So we get 1 minus 1.5. And we're checking to see if that's equal to negative 1/2, and that is indeed also equal to negative 1/2. So because 2 and 1/2 work for both equations A and B, then 2 1/2 is a solution. We'll just write that. Okay. Moving on, next example. This is what we did in Algebra 2. So solving each system of equations, we're going to look at a system with 2 variables, and then we'll look at the system with 3. 3 is a little bit more difficult. This is all working up to matrices, which we'll do in the next video. We're going to be solving systems with matrices for the rest of this chapter. Okay, I've got 2 equations, A and B. There are many ways that you guys can do this on your homework. I don't want you to graph because I haven't given you guys a graph on the notes handout, but graphing was an option. There was also substitution and elimination. So it's really up to you guys what you would prefer to do. I'm going to use elimination. So what I'm going to do is I'm going to multiply equation A by 3. And then I'll add these 2 things together. So what happens is we get 15x minus 3y is equal to 63. And we're going to add equation B to all of this. And we see that the y's are going to eliminate. We get 17x is equal to 51. Divide by 17. X is equal to 3. And then take an equation, A or B, doesn't matter. Plug in 3 everywhere we see x and solve for y. So 5 times 3 minus y is equal to 21. I'm using equation A here. 15 minus y is equal to 21. Negative y is equal to 6, which means y is equal to negative 6. So the final solution here is the ordered pair 3, negative 6. You can always check your work by going back in and plugging 3 and negative 6 in for x and y, making sure that both equations are true, or you can use Desmos to check your answers graphically. Next up, an equation, a system of equations with 3 variables. These get a little bit trickier. They just become a little bit longer. Unfortunately, matrices are going to help us keep everything a little bit more organized when we're looking at systems of equations with 3 variables, but they're still a little bit long. So I'm going to label these A, B, and C. That just helps me really keep track of my work. And we're not going to do it graphically here. We're going to do it algebraically. So either use substitution or elimination. Our goal with 3 variables is to first eliminate one variable and then eventually get to eliminating two so that we can solve for the third one. All right, if we take a look here, I think eliminating y's are going to be the easiest. So what I'm going to do is I'm going to take a and I will add c, and that will cancel all the y's out immediately. That is equation A. To that, I am adding equation C. All right, not a whole lot of work have to be done there. We get negative 2x, and then the y's go away. Plus z is equal to negative 3. I usually write a line through the z's so I can differentiate them between 2's and a variable. And then that resulting equation I'm going to call equation 1. And then now, because we used equations A and C, you need to find a combination of two other equations from our original problem. So either A and B or B and C, and we need to eliminate y in those as well. So I think what I'm going to do is I'm going to take equation A again, which is x minus 2y plus 3z is equal to 7. And what I'm going to do is I'm going to multiply b by 2, and I'm going to add those two things together. So when we multiply equation b by 2, we get 4x plus 2y plus 2z equal to 8. And then we see that the y's are going to cancel there nicely as well. We get 5x plus 5z is equal to 15. And then that resulting equation I will call equation 2. Okay, so we've got two equations now with just two variables, x and z. We're going to find a way to eliminate one of those variables using equations 1 and 2. Looks like we can eliminate the z's pretty quickly. If I take equation 1 and I multiply it by negative 5 and I add equation 2 to that, we'll be able to cancel the z's out. So equation 1 multiplied by negative 5 is going to be 10x minus 5z. Is equal to positive 15 because we're multiplying negative 3 by negative 5. And then equation 2 stays the same. And we get 15x is equal to 30, which means x is equal to 2. So we've got our first value. Now we're going to kind of work our way backwards. Go back to equations 1 or 2. It really doesn't matter. I'll pick equation 2 since I've got a little bit more space underneath it. I'm going to plug in 2 for x. And now I can solve for z. We get 10 plus 5z is equal to 15. 5z is equal to 5, so that means z is equal to 1. And then now that we've got x and z, we can go back to one of the original equations, a, b, or c, plug in 2 and 1 for x and z, and solve for y. I'll just pick the first equation here. X is 2 and z is 1. And now we just need to solve for y. This becomes 5 minus 2y is equal to 7. Looks like y is equal to negative 1 here. So our final solution then is the ordered triple, not a pair anymore because we've got three variables, 2, negative 1, 1. That's it. Okay, so review of Algebra 2. Solving equations in three variables. I'm going to do the next example is a word problem. Here we go. Financial planning. Okay, so we have $100,000 to invest in two investment options: bonds that yield 7% per annum, which means just per year or annually, and certificates yielding 4% per year. We want to know how much should be invested in each to realize exactly $5,000. So if we want to get $5,000 back on top of our $100,000 investment, how do we break up that $100,000 in order to get exactly $5,000? So how much of that $100,000 are we going to put into bonds? How much are we going to put into certificates? Okay, this is all about using systems of equations. So we need to set up a system of equations so we can solve for those variables. Here's what I'm going to do. I'm going to say an investment using bonds is going to be represented by the variable x, and an investment into certificates is going to be represented by the variable y. And I can set up a system of equations using x and y now. Okay, what do we know? Well, we know that the total amount of money invested in bonds plus the total amount of money invested in certificates is going to equal the amount of money that we're investing, that $100,000. And then we know that if we make 7% on bonds, so remember we never use the percentage in equation, we'll use the decimal value of that percentage. So 0.07 times the amount we invest in bonds plus 0.04 for the 4% we invest in certificates needs to add up to the $5,000 we're looking to earn. So that is my system of equations. I'm going to have you guys pause this video and solve for X and Y, and then I'll have the answers ready to go in a minute. Okay, we're back. Hopefully we got that we're going to invest $66,666.67 in certificates and $33,333.33 in bonds. I ended up eliminating X by multiplying A by negative 0.07 and then solving for Y. You could have easily done it the other way and eliminated Y. Okay. The second example, I'm going to have you guys, again, pause the video. I want you to do the whole thing. So you're going to set up the equation and then solve for X and Y. I will give you guys just the final answer, and then I expect to see your work when you turn the homework in. So same thing, but instead of that $5,000, we're looking for $6,000 per year. All right, your paper should have a lot more work than that, but essentially what happened when we were looking for $6,000 per year income, we ended up flipping the amount of money we invest in the certificates and bonds from part A. So that is it. Email me if you've got questions on that one. There's one more example we're going to get through, which is curve fitting, and then you guys, that's it. All you're doing is finishing this set of notes handout. Okay, so the last example here, we want to find the real numbers a, b, and c so that this function, y is equal to ax squared plus bx plus c, contains the points negative 1, 4, 2, 3, and 0, 1. So here's how we're going to approach this. Essentially, we've got three values of x and y. When x is negative 1, y is 4. When x is 2, y is 3. And when x is 0, y is 1. And I can set up now a system of equations, and then we can work on solving for A, B, and C. So what does that system look like? Well, the first equation, I'll call that equation A, is going to use the first point. Second equation, I'll call that B, we'll use the second point, and then we'll do equation C. So equation A looks like this. We're using this form, y is equal to x squared plus bx plus c. So all I'm going to do is I'm going to plug in 4 for y and negative 1 for x. That equation then becomes this. 4 is equal to a times negative 1 squared, well that's just a, minus b now because it's b times negative 1, and then c doesn't get multiplied by x. All right, so that's using the first point. The second point then says when x is 2, y is 3. So that, using the format y is equal to x squared plus bx plus c, gives us the equation 3 for y is equal to a times 2 squared, so 4a, and then plus b times 2, so 2b plus c. And then the last equation, this is a really nice one actually. When x is 0, y is 1. Y, or 1, is equal to, the first two terms go away because x is 0, c. So it's really nice. We got our first variable already solved for. Go ahead and solve this system of equations and then come back for the answer. All right, got our final answer. The equation, if we were to graph this parabola, 4/3 x squared minus 5/3 x plus 1, that's a upward facing parabola there. The parabola would go through those 3 points given. Obviously, I want to see a lot more work on this problem when you guys turn this in if you want full credit for the homework. Email me if you've got questions. All you're doing is just finishing the notes that I just walked through.